第三个是
Academic research was nothing new to these professors from different fields, but getting such a fractious team to collaborate over 5 years called for every bit of Yan's wisdom.
任何一个子计划拿掉，其他的计划通通停摆呀，是只要有一个人做错了，不做了，做不出来，通通停摆。所以这个复杂度呢，这个高得不得了啊。下一张，这个所以
Settling on a plan before undertaking the project, the carefully decided research direction and topic allowed a successful start to this first ever collaborative project between industry and academia. Machines are the essence of industry. They can be found everywhere, from daily life to aerospace technology. Machine project breakthroughs and advances bring social progress and make life convenient. Another research team with similar enthusiasm for research was devoted to machine product innovation.
那么在中国的古代非常出名的木匠，他名字叫做鲁班。鲁班呢，他曾经呢用木头来做了一只飞雀。
They were a group of teachers and students totally devoted to research in the field of aeronautics, based on their common passion for flying. Though neither a space shuttle nor a big plane, this tiny biomimetic aerial vehicle can still beat its wings and fly in the sky. This is the Nano Micro Electromechanical Systems Laboratory of Danjiang University, specializing in aerospace and micro electromechanical systems technologies. Professor Longjie Yang is conducting a series of experiments on the golden snitch with his students. You must certainly be curious about what exactly the golden snitch is.
我们知道西方有一部电影它那个里头有一个这个特别的飞行器它是模仿鸟类，有翅膀可以拍动的飞行的非常的灵巧迅速。它不像一般的模型飞机一般的模型飞机是固定翼的翅膀。那么我们金探子呢是有一对像鸟类的会拍动的翅膀，它没有螺旋桨，它完全靠着这一对翅膀来产生它所需要的力量，飞行在天上。
Yang smiled and said the naming of the golden snitch was inspired by the movie, in hopes that it can be just as light, delicate, nimble, and elegant as the movie demonstrates. Airliners used for carrying passengers are categorized as fixed-wing aircraft. In other words, the wings are fixed and air is thrust backwards by engines, generating a force relative to the aircraft body, and the propulsive force to fly forwards. Helicopters are rotary-wing aircraft. Their lift is produced by the high-speed rotation of the wing to cause upward lift of the aircraft. Changing the rotary tilt angle of the wing generates forward propulsion. However, the flight process of birds, unlike aircraft, includes takeoff, turning, and landing, which includes flapping, gliding, and hovering. So the principles by which birds fly are not exactly the same as the traditional knowledge of aerodynamics, utilized in making fixed-wing aircraft. In fact, there has long been research on fixed-wing aircraft in Taiwan, but virtually nothing on flapping-wing micro-aerial vehicles, or MAVs, based on a biomimetic interest. In 2000, the world's first successful examples of flapping MAVs appeared at the California Institute of Technology, Caltech, in the U.S.
这个 MAV 开始我是在我2000年在美国加州理工学院那做研习微机电技术的时候看到的。那他们是一个微机电的研究群，那居然去做微型飞行器，那我觉得蛮有趣的。这个就是他们在试飞的影片。那我觉得说一样是做微机电的这个技术，那为什么我们在国内不能试试看所以就把这个 idea 想办法带回国内。
The acronym MAV stands for Micro Aerial Vehicle and means a tiny flying robot.
其实它那个制作的关键就是怎么把它做小怎么把它做小。我们看到有国外的一些成功的案例我们觉得做小这可能不是太大的问题所以应该有信心。
Just like its namesake in the movie, the golden snitch was amazing. More importantly, it carried skyward the dream of flying held by teachers and students alike. But the process of making this dream come true took great effort.
就是先用自己裁切一些好像竹片等等的零组件，当然我们也做一些像钛合金的这骨架的辅石啊，还有买一些外面的现成的玩具的一些齿轮啊，来进行这个组装啊。那么一开始当然组起来是很丑啦，而且也很笨重啊，不过看先让它动起来再说，那样对。
From rough patchwork to wing flapping, in order to create a delicate gear transmission mechanism and prove that they could make an airplane small, they spent 2 to 3 years just verifying this step.
因为我们的拍翼机是上下震动的一个往复的一个拍动，那我们的动力来源是马达，马达是旋转的，所以从这个旋转到这个上下拍动中间要有一个传动的转换的机构。那这个机构呢，外面没得买啊。那国外已经成功的一些这个案例的那个机构，这个研究机构，他也不愿意卖，所以这个我们就得自己来想办法发展出来。
Since they decided to do R&D on their own, the features of a flapping wing MAV became the focus of the team's efforts.
关于这3个关键哈，第一个是材料的选用，第二个是它的气动力特性，第3个则是推进的效率，就是它可以飞多久的一个问题。
In choosing the materials with which to build it, the wingspan and weight of the flapping wing MAV were clearly far less than ordinary aircraft. They had to adopt materials with high strength-to-weight ratio for the structure. The rest of the equipment had to be miniaturized to reduce its weight and size. For the aerodynamics portion, since the scale of an MAV was tiny and its flying speed slow, a fixed-wing model was not suitable. Instead, they had to imitate the way small birds or insects flap their wings in nature. And the high-efficiency propulsion mechanism had to be kept within size and weight limits. In addition to producing sufficient propulsion for use by an MAV, they kept searching for high-power sources with a high energy density to extend its flight time and guarantee a wider range of applications for it.
它里面就是一个真空室我们呢就把飞机给放到里面去，抽真空之后它就可以镀。
Mastering these key points in order to localize flapping wing MAV technology in Taiwan, Professor Yang and his team initially had the goal of long flight endurance. They tried utilizing a kind of engineering plastic called paraline to serve as the coating for the wing skin, and used titanium alloy for the wing frame, combining it with a custom-made transmission system and tail. Thus, the first generation MAV prototype was born in June 2005. After that, the team utilized all sorts of light materials to enhance flying performance. In April 2006, a balsa wood frame, often used in making model planes, was adopted to make the second generation MAV. This MAV was successfully remote controlled to fly as far as 30 meters and stayed in the air for 10 seconds. During these years, the team worked on developing the Golden Snitch, an MAV with 20-centimeter wingspan, using innovative integration. Featuring a flexible carbon wing frame along with a custom-developed lightweight aluminum transmission system, the third-generation MAV Golden Snitch, loaded with a remote control module and battery, weighed less than 6 grams. It could fly as high as 10 meters and stayed in the air for 6 minutes and 7 seconds.